Right, let's start our class. Before we start, I just have a quick announcement. So our test number 2 will be on 14 July. 14 July means next week lah, on Thursday, right? Thursday, 14 July. Let me check pukul berapa. 14 July, 8 p.m. to 10 p.m. night, using a Google Classroom platform. So the chapter cover are chapter number 3 and chapter number 5 only, right? Okay, I letak dalam group lah, senang you nampak. Chapter number 3 and chapter number 5, the whole chapter number 5 lah. Okay. Alright, so in upcoming class, this Thursday, hari Khamis ni, we will have a lecturer daripada UKM to give us a talk on the last topic in chapter number 5, which is Neyman Personal Lemma. So I hope you all can attend the class on time. Alright, so let's start with the type 1 error, type 1 and type 2 error. So last class we already look at the definition of hypothesis testing, especially on simple hypothesis and composite hypothesis and so on lah. I think kita dah tengok, right? And we already know what is the null hypothesis, alternative hypothesis. So under null and alternative hypothesis, we have learned simple and composite hypothesis, right? So and then we also look at the statistical tests in hypothesis testing, either to use T distribution, Z distribution, F distribution, or chi-square distribution, right? And then we also know there are two types of error, right? In brief, last lecture we have type 1 error and type 2 error, right? Type 1 error means that when we want to find the probability of rejecting null hypothesis when the null hypothesis is true. When null hypothesis is true, we want to know what is the probability we reject null hypothesis. For type 2 error is the probability of accepting null hypothesis when alternative hypothesis is true. Means that when we are accepting null hypothesis when alternative hypothesis is true. So we want to know when an alternative hypothesis is true, what is the probability we accept null hypothesis. So that is the definition of type 2 error. So on last class also we have looked how to develop a decision rule, right? So we have learned what is the rejection area and acceptance area, right? Okay, so basically knowledge about introduction to hypothesis testing kita dah tengok semua until test of variance kan. So now today we're going to look at type 1 error and type 2 error in detail, right? So again, the possibility of drawing incorrect conclusion and inevitable byproduct of hypothesis testing lah. So no matter what sort of mathematical facet, right, in the decision process, So there are no way to guarantee that we're going to have 100% correct result, right? There will always be a percentage or probability of making a wrong result, right? So in order to avoid or avoid the wrong result, making a wrong conclusion. So we want to minimize the probability of making a wrong conclusion lah, which is a type 1 error and type 2 error. So again, definition of type 1 error is the probability of rejecting null hypothesis when null hypothesis is true, and type 2 error is the probability of accepting null hypothesis when null hypothesis is false, right? So this is the confusion matrix. In nowadays punya term is because we call it as a confusion matrix ataupun kita panggil probability versus predicted versus actual value, right? So dekat atas ni dekat column, this is the actual condition, which is actual condition, right? And this is our decision ataupun predicted lah, predicted, right? So let's say kita guna independent sample t-test, or we are using a linear regression, right? So we're going to have the predicted and actual value, right? So if you fail to reject null hypothesis, maksudnya we accept null hypothesis, right? So when the null hypothesis is true, then we are making a correct decision lah. If a null hypothesis is false, then we are making type 2 error. We accept null hypothesis, and null hypothesis is false, is a type 2 error. When we reject null hypothesis, right, but the null hypothesis is false, then we are making a correct decision. If we are rejecting null hypothesis and null hypothesis is true, then we are making type 1 error, right? So type 1 error normally known as alpha, type 2 error commonly known as beta, right? Type 2 error normally known as, the symbol for type 2 error is beta, the symbol for type 1 error is alpha, right? So the complement of beta, which is the power of the test lah, right? Power of the test is a 1 minus beta. Boleh faham, ha? So the probability of committing type 1 error is referred to test of level of significance, right? So this is the term lah that you need to know. And then one inference has been made, there are no way to know whether the conclusion reached is correct or not, right? So otherwise we can calculate the power of the test, or we determine the level of significance and type 2 error lah. So now let's look at example number 17. So in example number 17, right, example number 17, let me making some space here. Suppose that the manufacturer A of a new medication wants to test the null hypothesis theta equal to 0.9, right? So this is a null hypothesis theta equal to 0.9 against the alternative hypothesis theta equal to 0.6. So we have two statements here. Null hypothesis theta equal to 0.90. Alternative hypothesis theta equal to 0.60, right? So his test statistic is X, right? So the observed number of success in 20 trials, so this is a binomial problem, right? In 20 trials, so n equal to 20. He will accept null hypothesis if X is more than 14. So dia akan decision rule dia, decision rule, right? Accept null hypothesis when, sorry, dia kata apa? We accept null hypothesis if X is more than 14. Maksudnya X is more than or equal to 15 lah. So he will reject null hypothesis when X is less than or equal to 14. Right? So now the problem is find alpha and beta. So to find alpha and beta, solution here. So to find alpha is equal to, we write down the definition for alpha, which is type 1 error lah. Alpha means that we going to reject when the null hypothesis is true, we reject. What we want to know, what is the probability of rejecting null hypothesis. So reject null hypothesis when null hypothesis is true. So this is by definition, right? So the probability of rejecting null hypothesis when null hypothesis is true. So this is the definition for alpha. So let's make it into a mathematical form, right? So reject null hypothesis when X less than or equal to 14, when given that null hypothesis is true, which is theta equal to 0.90. Right? So this is the condition. So since from this statement we know that this is a binomial problem, right? So binomial problem, so we need to calculate the probability using a binomial distribution lah. So probability of X equal to 0 plus probability of X equal to 1 plus until probability of X equal to 14. So this one should be 20 choose 0, right? Probability of success is 0.9, power of 0, 0.1, power of 20, right? So ataupun you boleh buat daripada sini lah. I from 0 to 14, right? So C is N is 20, choose X, right? 0.9 power of X, 0.1, 20 minus X, right? So you input into the calculator ataupun you boleh tengok dalam statistical table, right? You should get berapa? 0.0.013, right? Kalau nak tengok statistical table macam mana? If you want to look into a statistical table, sekejap I take out Google Classroom. Sekejap. Statistical table you all ada kan? I dah bagi dalam Google Classroom, you boleh tengok. Right? So if you tengok statistical table, you know how to read the statistical table, right? Binomial distribution is table number 1. Right, table number 1, binomial distribution. But before we use binomial distribution table, let's look at the description. Always look at the description first before we read the table. So the probability of success in single trial, which is P and number of trial, right? The table gives a probability obtaining R or more success. Maksudnya daripada kecil ke besar lah. Right? So di sini it should be berapa? Kalau kita tengok dekat sini, the probability of success here is 0.9. So probability of success means this one lah, P is 0.90. But if you look at the probability value yang dia bagi dekat sini, we don't have much, right? We only have until 0.5, right? So if you only have until 0.5, so you can take the complement lah, right, of 0.9, which is 0.1, right? 0.1, and the probability mesti terbalik jugalah. From 20 tu maksudnya the balance dia kan, daripada 6 ke atas lah. So it should be R is more than R is N should be 20, right? And then 0.1 dekat sini lah, mana 0.1, this is a 0.1, right? And equal to 20, and then R should be 6 or more lah, which is 0.0113. Okay, boleh faham ah? Alright, so this is one part. We already find the probability of type 1 error. Kalau nak cari dalam table, in table, so cari guna probability of X more than or equal to 6, probability of success is 0.1, and equal to 20. Should get the same value lah. And then to find beta, right, let me make it more space, right? So beta is, what is the definition of beta? Accepting null hypothesis when null hypothesis is false, right? Probability of accept null hypothesis when alternative hypothesis is true lah, ataupun null hypothesis is false. So this one should be probability of accepting null hypothesis when X is more than or equal to 15. X is more than or equal to 15, given that alternative hypothesis is true, null hypothesis is false, alternative is true. So theta should be equal to 0.60. Right? So this is the condition. So sama juga tadi, in statistical table we cannot find the value of 0.5 and above, right? Kita boleh cari 0.6 and below saja, 0.5 and below, ataupun kita boleh manually calculate, right? So probability of X equal to 15 plus probability of X equal to 16 until probability of X mod equal to 20. Since we already have a calculator, you just plug in into value into the calculator lah, senang, right? So this starting from 15 until 20. So this one start from 20, choose X, 0.6 power of X, 0.4 power of 20 minus X. Right, so if you tekan the calculator, you should get 0.1256. Right, if you want to find in the statistical table, right, you can ingat ke sini, theta is 0.6. Dalam statistical table, there are no 0.6 and above. Right, they are until 0.5 only. So you need to use the complement. So it should be probability of di sini ada balance lagi 5 kan? Balance lagi 5. So probability of X less than 5, less than or equal to 5. And then the probability of success is 0.4, and then n should be equal to 20 lah, right? So kalau nak cari ni kena guna complement balik. 1 minus probability of x more than or equal to 6, probability of success 0.4, n equal to 20. Should get the same answer lah, 1, 2, 5, 6. Right? Okay? Boleh eh? Alright. So let's move to the example number 18. For Jones political pool, right, n equal to 15 voters are sampled. We wish to test null hypothesis p equal to 0.5 versus alternative hypothesis p less than 0.5. So this is a simple hypothesis, right? But in one tail test. So test the statistic. The test statistic is y, right? So the number of sample voter favoring Jones, right? So calculate alpha if we select rejection region, right? Y less than 2 as a y less than or equal to 2 as a rejection region lah. Alright. So now our alpha should be equal to probability of reject null hypothesis when null hypothesis is true. Right? Always remember this one. And this one should be probability of rejecting null hypothesis is y less than or equal to 2, given that the probability of success is true. Probability of null hypothesis is true is probability of success is 0.5. So same as previous example. So this is also a binomial problem because dia ada dua option lah. Either the voter favoring Jones or unfavor to Jones, right? So dia ada dua outcome, right? So and then there are the 15 trials, right? N equal to 15, right? So this is a binomial problem. So now by using binomial formula, y equal to 0 plus probability of y equal to 1 plus probability of y equal to 2, right? So tambah sajalah, tekan dalam calculator macam ni. Masuk dalam ni, I equal to 0 until 2. So this one to be 15, choose x, right? And then 0.5 power of x, 0.5 power of 15 minus x. You know how to using calculator? Oh, sekejap I tekan dalam calculator, tahu tekan calculator macam mana kan? Perlukah I ajar? Tak perlu kan? So shift, oops, shift this one. Oh, I don't want this. I think too complicated. Yeah. So this one should be from 15 choose, wait, I'm making this one 15 choose x, right, untuk kurungan 0.5 power of x, and then the one is 0.5 power of 15 minus x. So this one starting from 0 to 2. So you should get 0.000369. So basically approximately 0.004. Right? Boleh eh? So very simple. Let's look at example number 19. Ada soalan tak setakat ni? I think very simple, right? But not that simple lah. Suppose that we want to find the probability of committing a type 2 error in a gasoline experiment if the true mean, right, the true population mean with the additive were 25.750, right? So I think I'm losing some information here, right? Additional information dekat sini adalah n should be equal to 30 and the standard deviation should be 2.4 lah. Information kena ada, right? So we want to find the type 2 error, which is beta, which is equal to probability of we're not rejecting a null hypothesis, we are accepting a null hypothesis. Accept null hypothesis when null hypothesis is false, right? Kejap, I think the question is not enough information dekat sini. Suppose we want to find a probability of committing type 2 error in gasoline experiment if true sekejap. Alright, dekat sini mungkin I assume the mu is equal to 25.57, right? And another information yang missing adalah the condition of rejecting null hypothesis, right? So when satu lagi information, dia akan accept null hypothesis when y bar is less than 25.718. So this is another information lah. Missing. Right, this is a missing value dalam soalan ni. So if you come to my class, then you akan dapat the information lah. Yang tak datang tu, dia takkan tahu. Right? Right. So now, this one should be probability of y bar less than 25.718 given that mu is equal to 25.750, right? So we know the population mean population variance is 22.4 and n equal to 30. So to convert this to Z distribution, right, probability of y bar minus mu divided by sigma over square root of n less than 25.718 minus mu is 25.750 divided by sigma is 22.4 over square root of n is equal to 30. right? So this one should be equal to probability of z less than negative 0.07, right? So this one should be 0.4721. So what does it mean? It means that it means that 47% of the time um, kita akan accept null hypothesis lah. 47% of the time kita akan accept null hypothesis, right? Okay. Now let's move to example number 20. Refer to example number 18. So what is example number 18? Or Jones political pool, right? So in our test, is our test equally good to in protecting us from concluding that Jones is a winner? In fact, he will lose, right? So suppose that we will receive a 30% of the votes, which is probability of success is equal to 0.3. So what is the probability of type 2 error that the sample will erroneously lead to conclude null hypothesis is true and that Jones is going to win? So we want to know what is the probability that we're going to accept null hypothesis, right? So based on example number 18, is a binomial problem kan, either Jones is winning the pool or losing the pool, right? So initially dia ambil berapa, 15, sama jugalah example number 20 is still n equal to 15 lah. Kita boleh tulis kat sini supaya kita ingat n equal to 15. So dia ada dua probability, winning or losing, right? So now we want to know what is the probability that we will select null hypothesis, but actually null hypothesis is false, right? So which is type 2 error. We want to know what is the probability of committing type 2 error. So let's define the type 2 error, which is probability of accepting null hypothesis when null hypothesis is false, right? So accepting null hypothesis, kita tengok balik example number 18, right? So the rejection area, right, is less than 2, less than or equal to 2. So if you want to accept null hypothesis, y should be more than 2 lah, right? Y should be more than 2. And null hypothesis is false when probability is equal to 0.3. So this is a new P, right? So this one should be still same binomial problem. So summation of from 2, sorry, it's not from 2, it's from 3 until 15. So 15 choose x, probability of success 0.3 power of x 0. This is 0.7 kan. So atas tadi betul ke I buat 0.5, 0.4, yeah, correct, right. 0.7 is 15 minus x. So you just plug in the value. This is basically this is not x, huh? selalu menggunakan term X, but this is actually Y. Power of Y minus Y. Right, so just tekan dengan calculator. So, oops. This is starting from 15. Choose X. Multiply with 0.3 power of X. Multiply with 0.7 power of 15 minus X. So this is starting from 3 until 15. So it should be 0.873 lah. 0.873. Right, so this is a probability of committing type 2 error. Okay? Boleh? Right, good. So let's move to example number 21. Right. Example number 21, and then kita akan jump sikit lah. Okay. Suppose that we want to test the null hypothesis that the mean of normal population with sigma equal to 1, right? So when sigma is equal to 1 is basically approaching to standard normal distribution. Against it is mu naught against the alternative hypothesis, which is mu1, and where mu1 is greater than mu naught lah. So find the value of k such that x bar is greater than k, provide a critical region size alpha equal to 0.05. Okay, dekat sini, let me find some space. Apa yang dia nak cari dekat sini adalah, let's say this is a normal distribution kan. Oops. Tak cantik. Boleh lah. So this is the value of rejection area, right? Rejection area. So this is our alpha region kan. Alpha is equal to 0.05. So dia dah bagi dekat kita alpha. So now when alpha is 0.05, right? And we are looking into a normal distribution, right? We are looking into normal distribution. So we're going to use Z distribution kan? So this is going to be Z distribution lah. So Z alpha 0.05, kita tengok dalam statistical table. Table number, I think table number 4. This is table number 3, table number 4. 0.05, right, is 1.6449. 1.6449. So this one should be, this is the region critical value, 1.6449, right? So we want to find the value k, which is x bar more than k, provide a critical region. Maksudnya when x bar more than k, right? So this is a rejection area, right? Okay, when x bar more than k is a rejection area. So since we already know the probability of success, probability of type 1 error dekat sini, so we can simply find the value of k dekat sini lah, sebab kita dah tahu, dah define kan. So this one should be 1.6445 dekat sini. 449 ke 445? Kejap. 449. 449 should be equal to the value of k minus mu naught divided by 1 over square root of n. So remember z equal to x bar minus mu divided by sigma over square root of n. So when we are looking into a sampling distribution, chapter number 2, right? Remember? So now to find the value of k, right? Kita boleh manipulate this one lah, right? So this one should be 1k should be equal to mu naught minus plus 1.6449 over square root of n, right? Ni bawa ke sana, ni ke sana, right? So dia akan jadi macam ni, right? Boleh? Boleh faham? So now, still kita tak solve lagi problem. We just define what is k value, right? So now we are trying to use the information, right? Yang dia bagi tadi alpha 0.05, right? So to find k such that probability of x bar more than k equal to 0.05, right? Boleh relate ya this one, because probability of reject null hypothesis when null hypothesis is true, right? So we reject null hypothesis when x bar is equal more than or equal to 5, and null hypothesis is true when mu naught is apa nama, equal to mu naught lah. Mu naught is a null hypothesis, right? Mu naught is null hypothesis. Okay, so this is the condition, the definition yang first kita dapat. So now probability of x bar more than k is equal to probability of z more than k minus mu naught divided by 1 over square root of n lah, right? So we know from here 0.05 is equal to right, is equal to probability of z more than 1 k minus mu naught over 1 over square root of n. I think kita akan dapat lead soalan jawapan yang sama jugalah. So this is because we don't have the mu naught, value of mu naught kan, and we also don't have the value of n, right? Yeah, we don't have the value of n, we don't have the value of mu naught, right? So we want to find k. So k basically this one lah, right? So if you look into the statistical table, 1.6449 is equal to k minus mu naught divided by 1 over square root of n. Benda yang sama lah. So k should be equal to mu naught plus 1.6449 over square root of n. Okay, so let's look at example number 22. So example number 22, a random sample size 8 is taken from a normal distribution with unknown mean and variance, right? Sigma squared equal to 40. So here we have n equal to 8, mean equal to mean, and sigma squared equal to 40. So given a hypothesis testing statement, which is null hypothesis mu equal to 15, alternative hypothesis mu equal to 9. Let the critical region for the test be y bar less than or equal to 12.5. Right? If the following value observed 20 until this one, dia ada 1, 2, 3, 4, 5, 6, 7, 8, n equal to 8 lah. What is your decision? Alright, so now this is very simple, simple question. So we will reject null hypothesis if y bar less than 12.5. So this is the critical region, kan? Right? So y bar is equal to summation of yi divided by n. So 20 plus 19 plus 17 plus 24 plus 14 plus 9 plus 11 plus 15 divided by 8. So this one should be proper. I think 129 over 8. So this one should be 16.125. So since y bar is more than or equal to 12.5, null hypothesis is accepted. So we can conclude that the population mean mu is equal to 15. Okay? Boleh, eh? So now the question asks us to find the probability of type 1 error and type 2 error. Right? So let's do it one by one. Probability of type 1 error, probability of type 1 error, which is equal to alpha equal to probability of reject null hypothesis when null hypothesis is true. Right? So rejecting null hypothesis when y bar is less than 12.5. Null hypothesis is true when mu is equal to 15. Okay? Reject null hypothesis when the null hypothesis is true. So this is a normal problem, kan? Normal distribution. So this one should be probability of y bar minus mu divided by sigma over square root of n, right? So it should be 12.5 minus 15 divided by the variance equal to 40. So this one kita sum up together lah. 40 over n equal to 8. Right, so this one should be probability of z less than negative 1.18, and this one should be 0.1314. For the next question, dia kata find the probability of type 2 error. Probability of type 2 error is probability of not reject, we accept null hypothesis when null hypothesis is false. So accepting null hypothesis is probability of y bar more than 12.5 lah. When null hypothesis is false, which is mu equal to 9. Very simple kan? So probability of y bar minus mu divided by sigma over square root of n. 12.5 minus 9 divided by square root of 40 over 8 lah. So this one should be probability of z more than 1.565. So this one should be 0.0582. Okay. Right. Ada soalan tak setakat ni? If you don't have question, then I think kita try tengok example number 23 and 24 kita skip. Soalan yang lebih kurang sama. 25 also skip. 26 will skip as well. 26 kita tengok sikit lah sebab dia punya different distribution. Right. Sekejap Okay, kita tengok 23 lah. Right, example number 23. Let y1 until y5. Right, denote a random sample from a population with mean equal to mu and variance equal to sigma square. Right, null hypothesis mu equal to 1 against alternative hypothesis mu is equal to 2. The best critical region used is y bar more than k. Right. So next topic, which is Neyman Pearson lemma, we will learn how to find a best critical region. Sekarang kita tengok the type 1 error and type 2 error. Right. If the significant level of test is 0.05 and sigma is equal to 1, find the value of k. Right. Ini soalan lebih kurang tadi lah. Right. So dekat sini dia bagi tahu n equal to 5 and rejection region is y bar more than k, right? So A, probability of type 1 error, which is probability of reject null hypothesis and when null hypothesis is true, right? So probability of y bar more than k when mu h null equal to mu is equal to 1 lah, right? Okay. So this one kita tengok dia punya ni probability of type 1 error should be 0.05 lah, right? Probability of 0.05, right? So this one should be probability of z more than k minus mu divided by sigma over square root of n, right? So kita masukkan value lah dalam ni, probability of z more than k minus 1 over 5. Square root of 1 over 5 is equal to 0.05, right? So we know that 0.05, this one should be equal to, dalam statistical table kan, 1.6449 equal to k minus 1 divided by square root of 1 over 5 lah, right? Ataupun lebih senang kita letak 1 over square root of 5. Okay, so this one kita akan dapat berapa? This one senang nak cari k kan. Alright, so kita bawa ke sana. This is multiply with square root of 5 and plus 1 should be k equal to 1.7357 lah. Okay, so number B, let samples above show the following values 1, 2, 3, 4, 5, right? 1.4, 1.3, 1.9 until 1.5. So what is the conclusion? So the conclusion will be, kita tengok y bar dulu lah. So y bar should be equal summation of yi divided by n. So this one 1.4 plus 1.3 plus 1.9 plus 2.1 plus 1.5 divided by 5. So this one should be equal to 1.64, I think. So since k is equal to 1.7, right? Di sini. So since k equal to 1.7, decision rule, this is B, decision rule, kita tahu y bar is equal to 1.64, right? Decision rule is if y bar more than k, right? So this is the critical region, kan? So null hypothesis is rejected. So since y bar is equal to 1.64 less than k is less than k equal to 1.7357, null hypothesis is accepted lah, right? And then we can conclude that mu equal to berapa? Mu is equal to 1 lah. Okay, boleh right? So C, what is the power of the test? Remember in the beginning of the class, right, I dah bagi tahu, type 2 error is beta, power of the test is the complement of beta, 1 minus beta lah. So we need to find the power, the type 2 error first, right? So C, probability of type 2 error. So it should be equal to probability of accepting null hypothesis when null hypothesis is false, right? So to accept null hypothesis when probability of uh, y bar should be less than k, right? Less than k, less than k, and null hypothesis is true, false. I mean alternative hypothesis is true. Uh, mu is equal to 2, right? Tengok soalan balik So this one should be very simple. So probability of z less than k is 1.7357, right? We define k from the previous question. Minus mu is equal to 2 divided by sigma is equal to 1 over square root of 5. So this one should be probability of z less than negative 0.59, right? So this one should be, dalam tengok dalam table, dia dapat 0.2776. So this is the probability of type 2 error. So the power of the test is equal to 1 minus beta, which is equal to 1 minus 0.27776, right? So which is equal to 7224. Okay, right? Boleh So D, if if it is required that alpha remain to 0.05, so this is a complicated question. Alpha, we want to remain it to 0.05, right? Alpha, we want to remain it to 0.05, but beta, we want to reduce it to 0.1 instead of 0.2772 is quite big. We want to reduce it to 0.05. So we want to find a new critical value, and the sample size need to make it happen, right? So how many sample size we want to take, and what is the new critical value, right? So this one should be bawah sikit. Oops. So the last question D right? So this one should be alpha kita nak maintain 0.05, beta we want it to reduce to 0.1, right? So now kita try tengok one by one lah. What is the new sample size and what is the new critical region? So probably kita tengok dekat the first one dulu, right? We look at the first one, probability of type 1 error, right? Probability of reject null hypothesis when null hypothesis is true. So probability of rejecting null hypothesis, probability of y bar more than k, right? Remember just now mu is equal to 1 and this is 0.05, right? So probability of z more than k minus mu divided by sigma over square root of n. So this one should be probability of z more than k minus 1 over square root of n lah. We don't know the value of n. This is a 0.05. So this one 0.05, kalau tengok dalam statistical table is 1.6449 equal to k minus 1 over square root of n. Right, so we manipulate this one, solve for k equal to 1 plus 1.6449 over square root of n. So this is going to be your first formula. Right. So next we are looking into type 2 error. Probability of type 2 error, right, which is equal to probability of accepting null hypothesis when null hypothesis is false, right? So probability of y bar tadi besar, ni kecil lah bawah, and mu equal to 2, and probability of type 2 error should be equal to 0.1, right? So this one should be probability of z less than y bar less than k kan, less than k, sorry, right, less than k. So k minus mu, k minus 2 over 1 over square root of n, and 0.1 dalam statistical table should be equal to 1.2816, right? So dekat sini 1.2816, 2816 is it? Right, should be equal to k minus 2 over 1 over square root of n. So then k should be equal to berapa? Should be equal to negative 1.2816 square root of n plus 2, right? Wait, I think I forgot to mention, I just copy this answer kan, final answer. But you see, the region that we are looking into, right, for this one, be careful. So this is the region, rejection region, right? So when y is more than k, right? Y is more than k, it should be 0.05. Right? Dekat sini dia cakap apa? Sekejap. Alright. So since dia dekat sini dia cakap y is less than k, right, is 0.1, right, 0.1. So dia tak akan berada di sini, right? So this is more than k dekat sini, which is 0.05, right? This is for the first one, right? For the second one, we are looking in kejap. We are looking into less than, kalau dia tak lebih daripada 0.5, so dia tak akan duduk belah sini lah, so dia akan duduk di sebelah sini. So this is the y less than k, right, which is 0.1, right? So they are accepting that we are going to accept null hypothesis. Remember tadi yang asal dia rejecting null hypothesis, this is the critical region, right? Critical region is 0.05. This is rejection area, right? And the whole thing on the left is acceptance area. Right, please remember, pay attention on this. So since y less than k sama dengan 0.1. 0.1 dekat sini lah, satu area yang kecil sebelah sini. 0. This is a 0.1. So this is a negative k lah. Right. So since k negative, the value dekat dalam ni, right, this is bukan k lah, kita bagi j, right, the whole thing lah, the whole thing j. So dia duduk sebelah kiri, so kiri sepatutnya dia ada negatif lah dekat sini. It should be a negative part lah, right. So that's why the end result will be this one lah. Okay, so now, so we have two formula here, formula 1 and formula number 2. Okay, boleh nampak? So we try to solve 1 into 2, right? So 1 into 2, right? So let's put like this. K masuk dalam K jugalah. 1 plus 1.6449 over square root of n equal to negative 1.2816 over square root of n plus 2. Right. Bawa lah ke sana kan. 1.6449 over square root of n minus plus 1.2816 over square root of n. 2 minus 1 is equal to 1. Right, so this one should be 2.925 over square root of n or equal to 1. Right, so you can say that square root of n is equal to 2.925, and should be equal to the square of this one should be 8.55556 lah. 56. And sample size cannot be in decimal point, should be in the whole number, should be equal to 9. Right, so once we already define the sample size equal to 9, then we can find the value of k. Right, so either using the first one or the second one. Right, so k should be equal to, let's say, 1.2816 over square root of 9 plus 2. Right, should be equal to 157,333. Right, okay. Ada soalan? Right, let's move to other question. So example number 24 you buat sendiri, 25 buat sendiri, 26 26, yeah, kita boleh tengok. But 26 is a relation to chapter number 2, right? Relation to chapter number 2, don't forget. Now let y1 until y30 be a random sample from size 30 from a normal distribution with n sigma equal to theta and sigma, mu is equal to theta and sigma square equal to 3. So kita tahu kita ada y, let note some information there. Kita ada yi is having a normal distribution with theta and 3. So n equal to 30. Null hypothesis, theta is equal to 1. Alternative hypothesis, theta is equal to 3. So the critical region, right, rejection region, summation of I equal to 1 until 30 yi minus 3 square more than or equal to c, right? So I hope you're paying attention on this, right? So the question asks us to find c so that the significant level is alpha equal to 0.05. Okay. A, probability of type 1 error, which is equal to probability of reject null hypothesis when null hypothesis is true, right? So probability of summation of yi minus 3 squared more than or equal to c when null hypothesis is true, theta is equal to 1. Right. From here, we know that from chapter number 2, sampling distribution, what do you know? Right? Yi is having a normal distribution with theta and variance equal to 3. Right? And we know that when yi minus 3 over square root of theta, right? So this is a standard normal distribution, right? This is the first information yang kita tahu from our knowledge. When we are comparing to the rejection region dekat sini, yi minus 3 square, so yi minus 3, right? And you square, you're taking a summation dekat sini, right? Summation, okay, kita tak ambil summation lagi lah. This is kita squarekan semua kan. Let's say squarekan, right? So this become a chi-squared with 1 degree of freedom. Right, remember theorem number 2. Right, and then we go to theorem number 3. We're taking a summation of yi minus 3 squared over theta is this one from 1 until 30. So chi-squared with 30 degree of freedom. Right, so this is a chi-squared with 30 degree of freedom problem. So this is the value of type 1 error is 0.05. So now let's draw the distribution here, right? So this is the rejection area that we want to find, right? 0.05, and this is the chi-squared with 30 degree of freedom, and alpha 0.05, which is berapa? Kita tengok dalam statistical table, more than 30, chi-squared is table number 8. 0.05 here, right, kita nak ambil yang belah sana. 30, kita ambil 30 is 43.773, is it? Yeah. So this one should be 30 and this one should be 0.05, 43.773. So this one should be 43.773. Right, so this is the critical region. So we want to find C. So if summation of yi minus 3 square more than or equal to 43.773, null hypothesis is rejected. So C is equal to 43.773. Alright. So next question is we want to calculate or compute the power of the test if null alternative hypothesis is true. Use the C value obtained in A. So to find beta, which is probability of type 2 error, which is equal to probability of accepting null hypothesis when null hypothesis is false, right? So we want to calculate the type 2 error first before we can calculate the power of the test. So this one should be probability of summation of yi minus 3 square less than 43.773 lah, less than or equal to, right? And theta should be equal to berapa? Theta should be equal to 3, right? Because null hypothesis is false. So this one, theta here is about variance lah. Theta is a variance. So we just use the formula. So probability of summation of yi minus 3 squared over theta less than 43.773 over theta, right? So you will get the chi-squared with 30 degree of freedom. So probability of chi-squared with 30 degree of freedom less than 43.773 divided by 3. So this one should be probability of chi-squared 30 degree of freedom less than 14.5910, right? So you can find into a statistical table, right, which is equal to 0.99, right? Eh, 0.01 lah kan? Tengok dalam statistical table, right? 0.01, right? So this is 0.01 and power of the test should be equal to 1 minus beta equal to 0.99, right? Okay, ada soalan? I think example number 27 you can do it by yourself. Example number 28 you can also do it by yourself. 29 is the same example as previously. Benda yang sama, this is a chi-square distribution, right? You tengok betul-betul kita convert chi-square distribution. Type example number 30. I think better we look at example number 30 as our last example, right? So a continuous random variable x only takes in the interval of 0 and 1. The null hypothesis, it says that x has a PDF of 2 multiplied with 1 minus x, where x is between 0 and 1. And the alternative hypothesis, fx is 2x, 0 and 1 as well. A single observation is to be taken on x, and that suggests test procedure to accept null hypothesis unless the observation is greater than a constant c. Right, maksudnya kalau dia lebih besar daripada C, then we reject null hypothesis. We less than C, we accept null hypothesis. So the value of C is to be chosen as to minimize the value of P, where P is equal to the combination of two error, the probability of type 1 error and probability type 2 error. So we want to determine the value of C and the value of P. Right. So from here, we have two conditions. Our hypothesis statement, null hypothesis, where f naught x should be equal to 2 multiplied with 1 minus x, where x is between 0 and 1. Alternative hypothesis, f1 x should be equal to 2x, where x is between 0 and 1 as well. So the critical value yang kita ada dalam ni adalah kita akan accept null hypothesis, right, when xi is less than c, right? When xi less than x1 lah, dia single value saja kan. Single value is less than c. Kalau dia more than c, then we reject null hypothesis, right? So probability of type 1 error is a probability of reject null hypothesis when null hypothesis is true. So we're going to reject null hypothesis when xi more than c. And then null hypothesis is true is f not x, right? So this one should be integration from c to 1 lah, right? 2 1 minus x with respect to x, right? Okay, so this one should be 2x minus 2x squared over 2, right, from c to 1. So this one should be 2 minus 1 minus, right, 2 minus 1, yeah, 2 minus 1 minus 2c minus c square, right? This is square, kan? Okay, so this one should be equal to 1 minus 2c plus c square, right? So this is the type 1 error, and probability of type 2 error, which is equal to probability of accept null hypothesis when null hypothesis is false. Okay, so sama juga konsep dia. So we're going to accept null hypothesis when xi is less than c, when f1x. So we are integrating from 0 to 2, 2x with respect to x. Right, so this one should be x squared over 2x squared over 2. This is from 0 to c, right? And then this one should be equal to c squared lah. Alright. So the value of P is equal to probability of type 1 error plus probability of type 2 error. So which is equal to 1 minus 2c plus c square plus c square. So this one should be 1 minus 2c plus 2c square. Right? So we already have the value of p. So dekat sini dia kata, so the value of c is chosen so that to minimize the value of p, right? To minimize our value of p, we're going to differentiate p with respect to c, and then we're going to equate to 0 lah, and to get the value of p. So p is equal to 1 minus 2c plus 2c square. So minimize p, so differentiate p with respect to c. So this one should be negative 2 plus 4c, right? And then we equate this one to 0, right? So this one should be negative 2 plus 4c equal to 0, right? And then we can get the value of c lah. C is equal to 2 over 1 over 2 lah. 1 over 2. So once you already get the value of c, then substitute the value of c dalam p lah. P is equal to 1 over 2. This is 1 over 4, 1 over 2, 1 over 2. This is 1 minus 1 is 1 over 2 lah. 1 over 2 as well. Right. Okay. I think that's all. Ada soalan tak? I think that's all for type 1 and type 2 error, right? So next class we will look into a Neyman percent lemma. That one is regarding on finding a best critical region, right? So for this topic yang kita tengok hari ini is to find the value of probability of type 1 error and type 2 error only. And then next kita akan tengok the how to find the critical region lah. Okay? Ada soalan? Is there any question? No question. I think that's all. Thank you very much. Assalamualaikum.